In our lesson today, we're going to learn about writing repeating decimals as fractions. Irrational numbers are numbers that do not terminate or repeat. These types of numbers cannot be written as a fraction. This means that all repeating decimals must be rational so that you can write them as a fraction. All right, back in the fall, at the very beginning of the school year, we looked at terminating decimals and we learned how to write those as fractions. Remember that when you change a terminating decimal into a fraction, you need to first say it. Okay, say the decimal out loud properly. This means that 0 and 34 hundredths is 34 hundredths and not 0.34. Okay, so make sure that you know how to say your decimals properly. If you can say the decimal properly after you say it, then you can write it. By saying the decimal out loud, we know that the furthest right place, right place value. In the example above, it's hundredths. Okay, so right here we go to the hundredths place. Now write 34 hundredths as a fraction, 34 over 100. Once you say it and then you write it, the last thing that you need to do is simplify it. Okay, if possible, simplify the fraction into lowest terms. In our example, 34 and 100 are both divisible by 2, which creates the simplified fraction of 17/50ths. And since it will not simplify further, we know that 34 hundredths is equal to the fraction of 17/50ths. So now that we've reviewed how to write a terminating decimal as a fraction, let's go ahead and practice that. Write each terminating decimal, as a fraction in simplest form or as a mixed number. Okay, so here's our first decimal. And again, we're going to say it properly. It's not 0.8, right? The 8 is in the tenths place, so this is called 8 tenths. So I'm going to write it as the fraction 8 over 10. 8 tenths, 8 tenths. And now I'm going to simplify it. The numerator and the denominator are each divisible by 2. So that's going to simplify the fraction down to 4/5. Okay, right underneath of that. All right, again, this is not 0.02. The 2 is in the hundredths place, so this is called 2 hundredths. So I'm going to write my fraction as 2 over 100. And now I'll simplify. Both the numerator and the denominator are divisible by 2, which makes the fraction 1/50th. In our next our next decimal, 3 and 25 hundredths. So this is going to be a mixed number where the whole number is 3, and then 25 hundredths, 25 over 100. Okay, now when I simplify this, I'm still going to have 3 as my whole part, and then 25 100ths. They're both divisible by 25, which creates the fraction 1/4. 3 and 1/4. Or if you change that to just a fraction, this is going to be the same as 13 fourths. Finally, 5 and 44 hundredths. So again, another mixed number. 5 and 44 over 100. 5 and 44 hundredths. I'll divide the numerator and the denominator here by 4. Excuse me. Yep, by 4, which is going to be 5 and 11/25ths. In simplest form as a mixed number. As a fraction, 25 times 5 is 125. 125 plus 11 is 136/25ths. So again, to write a terminating decimal as a fraction, say it, write it, and then simplify it. So now that we've reviewed how to write a terminating decimal as a fraction, we're going to talk about repeating decimals. Sometimes decimals will repeat in a specific pattern. Decimals that repeat are usually written in bar notation, where a line is drawn above the digit that repeats. When we convert a repeating decimal to a fraction, we'll take an algebraic approach. Okay, so we've done some algebra word problems in the past. Step number 1, the first thing we're going to do is write a let statement defining a variable to be equal to the repeating decimal. Step number 2, I'm going to multiply my variable and my repeating decimal by the same power of 10. And then step number 3, I'm going to subtract my two equations, my two let statements from each other, and then I'm going to solve for the variable. Okay, so this is the process that we will use to convert any repeating decimal into a fraction. In our next example, we're going to write the decimal 3/10 repeated as a fraction in simplest form. And if we recall from what we were just saying before, the first thing that we're going to do is to write a let statement defining a variable to be equal to the repeating decimal. So in this example here, we're going to say let x, and you don't have to use x, you can use any variable you want. I'm going to use x. Let x equal my repeating decimal, which is 3/10 repeated. Okay? Now, the next thing I'm going to do, step number 2, it says multiply your variable and repeating decimal by the same power of 10. When I look at the decimal 3/10 repeated, okay, there's only one number that's repeating, okay? It's this 3 that's in the tenths place. All right, since there's one number that's repeating, I'm going to move the decimal point one time to the right. And so mathematically, to move the decimal point one place to the right, you have to multiply by 10. So I'm going to multiply my variable by 10. So I'm going to say let 10x equal. Now I'm going to multiply my decimal by 10 as well. 3/10 repeated, if you multiply by 10, is going to move the decimal point one place to the right. So it's going to be 3 and now after this 3, remember, is a whole bunch of other 3's that repeat. So 10x is going to equal 3 and 3/10 repeated. So since there was only one number that was repeating, I'm going to multiply both sides by 10 in order to move the decimal point one time to the right. So I have two different let statements now. These are my two equations. And step number 3 says to subtract the equations from each other and solve for the variable. All right, well, 10x is bigger than 1x. So I'm going to start with this part, this equation. 10x, which is equal to 3 and 3/10 repeated. And I'm going to subtract x, which is the same as subtracting 3/10 repeated. I'm going to bring my equal sign straight down. And now I'm going to simplify each side of the equation. Here on the left, 10x minus x, remember that's the same as 1x. 10x minus 1x is 9x. On the right-hand side, I have 3 and 3/10 repeated minus 3/10 repeated. Well, these repeated 3's right here are going to make 0. 3/10 repeated minus 3/10 repeated is 0. So I'm really just going to do 3 minus 0, which is just 3. All right, 3/10 repeated minus 3/10 repeated is equal to 3. So the equation now says that 9x is equal to 3. Now I'm going to solve for x. This is a one-step equation. To get x alone, I have to divide by 9 on both sides. 9x divided by 9 is equal to x. And this is the fraction right here, 3/9. 3 divided by 9 is the fraction 3/9. So x is equal to the fraction 3/9, which I can simplify down to 1/3. 3 and 9 are each divisible by 3. So in simplest form, my fraction is 1/3. So my decimal of 3/10 repeated is equal to the fraction of 1/3. So this will be our process every time. Write down our let statements, and then we'll subtract our let statements and our equations from each other, and then solve for the variable until it's in its simplest form as a fraction. In our next example, we're going to look at a repeating decimal with a non-repeating digit. Write the decimal 16/100ths, where only the 6 repeats, as a fraction in simplest form. Okay, so we have a digit that doesn't repeat, that 1, and a digit that does repeat, the 6. We're going to write this decimal as a fraction. We'll start out by writing our let statements. Let x equal 16/100ths with the 6 repeating. And now I'm going to write another let statement. Well, if I look at this decimal, again, there's only one number that repeats, that's 6. When there's only one number that repeats, I'm going to move the decimal point one time to the right, which means I have to multiply by 10. So let 10x equal, if this decimal point moves one time to the right, this is now going to be 1 6/10 repeated. All right, so x is 1600ths where the 6 repeats, 10x is 1 6/10 repeated. Now I'm going to subtract these two let statements from each other. Again, 10x is bigger than 1x, so I'll start with this one first. 10x, which is equal to 1 6/10 repeated, I'm going to subtract x, which is the same as subtracting 0 1600ths, where only the 6 repeats. Okay, so looking at the right-hand side of the equal sign, 10x minus x is 9x. And now here on the other side, okay, so this 6 repeats forever. So after this 6 is another 6, which is going to repeat forever. So I can actually go ahead and remove the bar from that first 6, okay. And now here's where my 6 is repeating. Okay, so if I go ahead and I do my subtraction, this repeated 6 and this repeated 6 are going to make 0 when you subtract. So really, I'm going to do 6 minus 1, which is 5. Bring down the decimal point, and 1 minus 0, which is 1. 9x is equal to 1 5/10. Again, these repeated 6's when we subtracted make 0. So now I have to get x all by itself. So again, I'm going to divide each side by 9. And x is equal to the fraction 1 5/10 over 9. Now, I don't like this fraction because in the numerator, I don't have a whole value. I have a decimal. To make this a whole value, I need to move the decimal point one time to the right, which again is multiplying by 10. So this is going to be the same as 15 over, well, if you move the decimal point to the right here, you have to move the decimal point to the right here. 9 times 10 is 90. Okay, so this is really the fraction 15/90ths. And now I'm going to go ahead and simplify this. 15 and 90 are each divisible by 15. 15 divided by itself is 1. 90 divided by 15 is 6. So there's my fraction in simplest form. So the decimal 1600ths with the 6 repeating is equal to the fraction of 1/6. In each example that we've done so far, there's only been one digit that repeats. What if there's more than one repeating digit? Write the decimal 2 900ths repeated as a mixed number in simplest form. Okay, so right here, this 900ths is repeating. Okay, so I'm going to write this as a mixed number in simplest form. Right, so I'm going to ignore the 2 for right now. Okay, and I'm only going to focus on what's repeating right here. So I'm going to say let x equal 900ths repeating. All right, x equals 900ths repeating. Since there are two numbers that are repeating, two digits that are repeating, I need to move this decimal point to the right twice. Mathematically, to move the decimal point to the right twice, you need to multiply by 100. So my next let statement is going to say let 100x equal, and now if this decimal moves to the right twice, once, twice, I'm going to have 9 900ths repeated. Remember, 0, 9, 0, 9. Okay, so if the decimal moves right here, this is just now where the repeated 900ths is. So x is 900ths repeated, 100x is 9 900ths repeated. Now let's go ahead and set up our subtraction. Again, we'll do the bigger x first. 100x equals 9 900ths repeated. Subtract x from that, which is the same as subtracting 900ths repeated. And now 100x minus 1x is 99x. And on the right-hand side, 900ths repeated minus 900ths repeated, this makes 0. 9 minus 0 is 9. So 99x is equal to 9. And now we're just going to go ahead and divide each side by 99. 99x divided by 99 is x, equals the fraction 9/99ths. But we can easily simplify that down to 1/11th when we divide both parts by 9. So 2 and 900ths repeated is going to be a mixed number. So I'm going to have the 2 still, but now the fraction for 900ths repeated is equal to 1/11th. 2 and 900ths repeated is equal to 2 and 1/11th. So now that we have a pretty good hold on how to change a repeated decimal into a fraction, let's just practice with a couple more examples, all right? I want to do example B with you. All right, the decimal is 4 and 3500ths repeated. So this is actually going to be a mixed number. So I know this is going to equal 4 and something. I just have to figure out what that fraction is going to be. So let's let x equal the repeated decimal of 3500ths repeated. Since there are two numbers that are repeating, I need to move the decimal point twice to the right. So I'm going to have to multiply both of these by 100. So let 100x equal 35 and 3500ths repeated. Okay, remember that 35, 35, etc. This will move here, and now that's repeating. And now let's set up our subtraction. Bigger x first, 100x, which equals 35 and 3500ths repeated. Subtract off the single x, which is going to subtract off 3500ths repeated. 100x minus x is 99x, and that equals, well, 3500ths minus this 3500ths repeated. That's going to make 0. 35 minus 0 is 35. Now divide each side by 99 to get x alone, and x is equal to 35 over 99. Okay, and we just have to make sure that that is in simplest form. Okay, and, well, I can't think of any factors that these two numbers share besides 1. So this is in simplest form right here. So coming back up here, 4 and 3500ths repeated is going to be the mixed number 4 and 35/99ths. Okay, let's go right underneath of that and do example D, where we only have one repeating digit, but there's a non-repeating digit as well. That 8 isn't repeating, but the 3 is repeated. Let's write 8300ths with only the 3 repeating as a decimal, or as a fraction rather, in simplest form. Okay, so let x equal our initial repeated decimal, 8300ths, with the 3 repeating. Only one number is repeating, so I'm going to move the decimal point once to the right, so multiply both of these by 10. Let 10x equal, the decimal is going to move here now, 8 and 3/10ths repeated. Now I'm going to go ahead and set up my subtraction, bigger x first. 10x equals 8 and 3/10ths repeated, minus x, which is going to subtract off 8300ths with the 3 repeating. Okay, now there's nothing above this 3/10ths repeated, but remember, after this 3 is a whole bunch of other 3s, so I can actually put my repeated spot there. I'll erase the repeated part right there. Okay, so now this 3 repeated and this 3 repeated would make 0. And now I have to do 3 minus 8, which I really can't do. I'm going to borrow. That would become a 7. That becomes a 13. 13 minus 8 is 5. Bring down the decimal point. 7 minus 0 is 7. Equals 10x minus 1x is 9x. Now to get x all by itself, divide each side by 9. And x equals the fraction 7 and 5/10ths over 9. But again, we don't like having a decimal in our numerator, so I'm going to move that decimal one time to the right, which means I have to do the same thing down here. This is going to turn into 75/90ths. And now I'm going to simplify that. 75 and 90 are each divisible by 15. Earlier, we said 90 divided by 15 was 6. 75 divided by 15 is equal to 5. So our fraction in simplest form is 5/6. 83 hundredths with the 3 repeating is equal to 5/6.